Welcome to this explainer. Today, we're taking a super precise, analytical look at the foundational logic of the periodic table, and we're drawing on some really fantastic insights from Careers 360. We're moving way beyond just the basic layout you might remember to decode the absolute mathematical structure that governs the elements, their symbols, and their atomic numbers. It is literally a masterpiece of scientific organization. And, understanding the deeper logic behind its arrangement, well, it gives us a much sharper perspective on exactly how our physical reality is put together. Let's get into it.
Okay, let's dive into this with a classic anomaly straight from our source material. Why in the world is hydrogen represented by the letter H while potassium is represented by K? It's the absolute perfect entry point for us today, right? Because it highlights right off the bat that the periodic table isn't just some simple list of English abbreviations. And honestly, this brilliantly illustrates the apparent chaos and unpredictable nature of chemical nomenclature. I mean, hydrogen being H is perfectly predictable, makes total sense. But potassium being K, that is completely unexpected if you're just looking at the English alphabet. Now, while our source text doesn't explicitly dive into the ancient Latin or Greek roots of these words, it specifically highlights this exact contrast to validate your confusion and prove a vital point. To truly read this table, we absolutely have to look past the surface-level alphabet. The letters alone, they just don't provide a reliable structural framework. Because alphabetical symbols can be so historically complex, like our friend K for potassium, chemists desperately needed a rigorously absolute system. So, what is the logic behind assigning each element a unique atomic number? Well, we need a foundational mathematical order that leaves zero room for linguistic ambiguity, no guessing games whatsoever. So the crucial point is that the atomic number is the ultimate organizing rule. It's far more than just a simple serial number tacked onto an element. It is the foundational value that, when combined with an element's properties, dictates its exact, unchangeable placement on the grid. The atomic number basically strips away all that messy linguistic history to provide pure mathematical placement. Simply put, if you know the atomic number, you know the element's absolute position. An element's identity relies on three distinct pillars. Think of it like a highly secure ID badge or an exclusive passport. Every single element possesses a unique name, a unique symbol, and crucially, a unique atomic number. Even when the symbol completely defies our modern linguistic expectations, the strict combination of these three traits serves as a foolproof registry. It's an elegant system ensuring no two elements are ever confused. Now, take a second and think about this. Exactly 118 distinct elements make up our entire known physical reality. That is it. From incredibly distant star systems all the way down to the exact device you're using to tune in right now, literally everything is constructed from this very specific, finite menu of ingredients. It is absolutely awe-inspiring. Let's move to the macro view and see how this builds a complete system. The periodic table contains exactly these 118 distinct elements. This is the complete, current inventory of matter. It seamlessly brings an incredibly diverse range of physical materials together into one cohesive, logically structured map. It's the whole shebang. Of course, naturally, managing 118 individual profiles requires a broader level of organization so we don't just descend into pure chaos. To structure this massive collection, the elements represent a wide range grouped into these digestible families based on shared behaviors, things like metals, nonmetals, and noble gases. This predictive family tree is brilliant because it allows chemists to instantly understand how different elements are going to interact simply by noting their broader categorical grouping. It shows that, in the end, order reigns supreme. Which brings us to a really provocative question to conclude with today. Which of these 118 elements makes up your world? Think about it. The air you breathe, the architecture around you, your own biology. It is all cataloged right there within this beautifully organized grid. The periodic table isn't just some dusty inventory. It's the fundamental mathematical order of nature itself, beautifully visualized. I really encourage you to dive deeper into chemistry and find the answer for yourself. Thanks so much for joining me for this explainer, and hey, stay curious.